The solar power industry value chain consists of the upstream sector, the midstream sector, and the downstream sector. The primary manufacturing process for silicon wafers is to first fill a solidification furnace with polysilicon, then melt, refine, and extract the deposited ingots. These are then cut and separated into the bricks, which are inspected for cracks and inclusions. Next, carrier lifetime and resistance value are measured. Afterwards, the both ends of the bricks are cut, and the corners of the bricks are chamfered. The surfaces are then polished and the bricks are sliced. Next, the final cleaning is performed. After inspecting their external appearance and electrical characteristics, each wafer is graded, and then the completed products are shipped out. TSEC primarily produces and sells crystalline silicon solar cells. This is an estimate of the market share distribution of various solar cells by type. It is anticipated that crystalline silicon solar cells will remain mainstream through 2025. The structure of normal solar cells consists of the joint of P-type semiconductors and N-type semiconductors. In principle, solar cells generate power by converting sunlight energy to electrical energy by using these two different types of semiconductors. In the solar cells, P-type semiconductors and N-type semiconductors are first joined together to form positive and negative electrodes. When sunlight shines on the solar cells, the photon energy excites the electrons in the semiconductor material to produce electron-hole pairs. The electron-hole pairs are subject to the internal electric field formed by the p-n structures in the solar cells and then driven to separate. This causes electrons to move to the negative electrodes, while the holes move to the positive electrodes. Finally, the positive electrodes, the negative electrodes, and the loads in a series are connected by conducting wires to form circuits. As a result, electric currents are generated to supply external loads. The primary step for manufacturing the solar cells is to first etch the surfaces of P-type crystalline silicon wafers using an acidic liquid solution. Then, the texture is formed. The wafers are coated with phosphorus to form an N-type layer through thermal diffusion. The phosphorus glass generated on the surfaces of the wafers during the phosphorus diffusion process is then removed. Next, an anti-reflection layer is formed on the surfaces of the wafers using a PECVD procedure. Then, fingers and bus bars are screen printed onto the front and back surfaces of the wafers to form electrodes. Afterwards, co-firing enables current to flow through the metal paste onto the wafers. The edges of the wafers are then laser isolated and the electrodes are insulated. Finally, the external appearance and electrical characteristics are inspected and each cell is graded. The completed products are then shipped out. The primary production process for solar modules first starts from washing the glasses. Next, put the EVA cover sheets on the glasses and lay up solar cell stringings on the EVA cover sheets. Afterwards, solder solar cell stringings buses. Then, the EVA cover sheets and the back sheets are covered over solar cell stringings. Next comes the laminating and edge trimming stage. This is followed by mounting frames, and then junction boxes are attached and mounted. After the electrical characteristics are inspected and output classification is performed, the completed products are shipped out. Solar generation system installation volume in 2011 is estimated to reach 18.9 gigawatts worldwide. In particular, Germany will reach about 6.8 gigawatts, while the rest of Europe is expected at approximately 5.8 gigawatts. Meanwhile, the USA is expected to reach 2.1 gigawatts, and Japan is poised to achieve 1.1 gigawatts. The remaining countries of the world will roughly achieve 3.1 gigawatts. The global installation volume of solar generation systems from 2010 to 2014 is estimated at 16.3 gigawatts for 2010, 18.9 gigawatts for 2011, 22 gigawatts for 2012, 26.6 gigawatts for 2013, and 31.8 gigawatts for 2014. However, the global solar power generation market is just beginning to take off. The total amount of solar power currently generated in the world accounts for only 0.23% of the total demand for electric power worldwide. As the total global installation volume is estimated to reach 5,000 gigawatts by 2035, it is evident that there will be a strong demand for solar power in the foreseeable future. Of the estimated 15.6 gigawatts of global solar cell production volume in 2010, Taiwan possesses an estimated production volume of 3.77 gigawatts. This means that Taiwan has already exceeded 24% of the global volume and has already exceeded 20% of the world's production capacity. Manufacturing solar cells is an intensive industry that requires capital, technology, and effective management. From this perspective, Taiwan's world-class technical abilities and superior corporate management ensure that Taiwan will continue to hold a strong position as the primary exporter of the solar cells in the world. TSEC is to construct a solar cell plant with an annual production capacity of 1.5 gigawatts in the Hsinchu Industrial Park of Taiwan. The first stage 500 megawatt production line will be set up in May 2011. The second stage 500 megawatt production line will be built in 2012, expanding the annual production capacity to 1 gigawatt. And the third stage 500 megawatt production line will be built in 2013, expanding the annual production capacity to 1.5 gigawatts. TSEC possesses superior technical teams to research and develop high-performance and high-quality products through the use of cutting-edge technology and mass production facilities. TSEC provides superior services to customers worldwide. TSEC is also building strategic business relationships with major global upstream and downstream companies and is establishing a strategic position with strong competitive advantages in the global PV industry. All are welcome to visit our booth, where you may see actual samples of our products as well as materials. More information and a copy of this presentation are also available at our booth.